Okay, so here's my little JVC camcorder, and it's a model GZ-E-100 BU. Now, I only had it about 6 months, and it's a great little camcorder, but then it fell off a table and it wouldn't work at all anymore. Wouldn't turn on, nothing on the screen. And when I plugged in the charger, I would get 9 flashes on the battery. That's all I would get. I would get 9 flashes and it would stop. And here you see I have it apart, or it's mostly back together. This side covers off it right now. So I took it apart, thinking that possibly, like, see if I could fix it, because it wasn't. I never bought the warranty. So first of all, I thought it might be the battery. Well, I took it apart to see if anything obviously was wrong. I took the whole thing apart. Now, you have to, before you work on something like this, you have to have the right tools. You have to have a magnifier, because a magnifier is the greatest thing for working on small electronics. And this is very fine-pitched electronics. So, I took the whole thing apart. I couldn't find anything wrong with it. So then I thought maybe the battery, when it fell, the battery hit hard, and inside here, on the other side, I thought maybe the solder got dislodged or something. So anyway, I resoldered that. Still nothing. And I took it apart a number of times trying to fix it, and I figured I've got nothing to lose. You have to be very careful. You have to use the right tools. You have to use a very fine screwdriver. Now, you keep track of the length of the screws as you're taking out of them, because they're all different lengths. But basically, I was able to fix it. A miracle, pretty much. So this camcorder, you start by taking off this cover here, and it all comes apart quite easily. Like here, we're going to take off the slider for the. I'm going to loosen the screw, then I'll use some tweezers to take the screw out, and then put the screw over here. Now that comes off. Okay. Now the back comes off easily too. Now the back is your power supply, where the battery and the charging system in. So there's 2 screws on the back. There's the one up here and the one down here. And the back, you don't need to do this, I'm just telling you. What was wrong, what happened was, the last thing I thought I'd check. Now, I was thinking, I'm not getting anything out of the camcorder, so maybe it's the door switch, you know. But that 9 flashes was throwing me off a bit. Now, how does the door switch work on these little camcorders? Is there a switch, or is it a Hall effect sensor, or what? Anyway, so I had this all apart, the cover off it, and inside the door hinge here, there's a little tiny puck magnet. It's about the size of an end of a eraser, or it's about 150 thou in diameter and about 60 thou thick. It's like a tiny little battery, and it sits in here. And when the door closes, it goes up against the Hall effect sensor here on a tiny little ribbon circuit board that goes over the top. Now, so that circuit board, this cable here on this here is the one that goes over the top of the camera and down to the. It brings all the signals back from the screen display here and the door switch Hall effect sensor. So what I did was I traced the wires. The Hall effect sensor is about the size of a piece of fly shit, so I don't even have the probe or the tools to work on something that small. Anyway, I traced the wires on the Hall effect sensor on this ribbon cable. They go into the ribbon cable, and it turns out they are the 2 end wires here. And so what I did was I put it all back together. I had the whole camera apart. The whole center optic sense cartridge comes out. You don't take that apart, but actually you don't have to take the camera apart at all to fix this problem. Now, So I put the camera back together, and the two end wires on this ribbon cable, I'm getting awful close here with the camera, the two end wires on the ribbon cable here, I touched it with the battery on. I touched them together with the end of a resistor, because using my magnifier, I reached in with the magnifier. Let me see if I can use the magnifier to see this here. And anyway, I touched the two in, and sure enough, the camera came on. So that's what the problem was. Now, so if you have this model, or probably a lot of them, you could trace the wires and make sure you got the right ones. But when I touch the two together here, it bypasses the Hall effect sensor, and the camera will turn on. So what I did was, these wires are too fine to solder to, and I have a fairly fine pitch soldering iron here, but they're too fine to solder to. It's also lead-free solder on the camera. So what I did was, with the battery disconnected, of course, at that point, if you're going to work on the camera, disconnect the battery. I put a tiny little bit of solder bridging these two pins. That makes the camera on all the time. And all you have to do is remove the battery when you're not using it. So at least the camera works. Anyway, I don't, I've gone through a couple of cameras, and I'm getting, it gets kind of expensive. And this was a really good little camera. I like it. So if you make the camera on all the time, all you have to do is remove the battery or just let the battery go dead every time you use it, and then take the battery off and charge it. It's better than nothing. But the other thing you can do is remove the back part here. Like these right here, it's too small to add a switch. You could add two wires. I mean, it's possible you could add two super fine wires here, bring them out and add a switch. But the best way to do it is to solder this together so it's always on. In the back power supply here, where the power comes off the battery, now you have to study the battery and see which are the power wires. Actually, there's a little legend right there. It tells you which is the power wires, the plus wire. I haven't done this yet, but I probably will. Remove the back here, and just, these ribbon cables actually can be disconnected by flipping this little black thing here. If you flip this little black thing, I don't know if you've ever worked on a PS3, but you can, the little black thing is a little latch to secure the ribbon cable. If you want to remove the ribbon cable, just flip that, and the ribbon cable will come free, and then next, just shove it back in and flip it back down. It's a little lock. So if you were to open the back of here, cut the power trace, which is a much bigger trace, put your switch there, run two little tiny wires. Now, here is some very fine wire, extremely fine wire. I use it all the time. And you could solder the two of them, cut the trace on the power lead, solder the two of them, and twist them together. And actually, what you should do is put the wire close to the circuit board. After you do that, put a dab of epoxy to secure it. Then bring them off and add a little slider switch somewhere. You could do that too. Anyway, it works, and I'll just show you. If I put the battery in, I took it to, I didn't know if it was the battery was dead or what, but I took it to a future shop, and they told me my battery was fine. And there's my camcorder working. And then if you take it off play mode, there it is there, the zoom in and out. It's working fine. And all I do is remove the battery. Now make sure, if you're going to remove the battery to shut it off, never remove the battery while it's recording, or it'll probably glitch your SD card. So just make sure you stop it and then you remove the battery. Anyway, I got it working amazingly. I just want to add that what probably causes the Hall effect to fail. And it isn't the shock, it isn't the dropping, it's when you drop the camcorder, probably it makes the magnet do a severe jerk. Like the dropping causes the magnet to do a severe fast jerk, and that jerk causes an electrical spike. Because you move a magnet very fast, you get electricity, just like they would on if they were in nuclear. What do they call that? Where they knock out all electricity. So this is a flaw in a lot of things with a magnetic door sensor. That if you drop something, the magnet hits the ground and makes a sudden jar. That causes a spike in the current going to the Hall effect sensor and pops the circuit or pops a transistor inside there. Because the Hall effect sensor senses magnetism, and then it has a little amplifier that picks up some kind of a sensor. Now it could just be a trace, a trace on the board or something, but when you drop the magnet, it's so fast that it exceeds the voltage of the transistor or the little amplifier in the Hall effect, and it blows it. So this same problem could probably happen to cell phones or a lot of things where you have a magnetic door switch. Now, see the door switch isn't using a magnetic switch like a mechanical reed switch or anything. It's using a Hall effect sensor, so that's susceptible to blowing. You could change it, the sensor, but it's extremely small and delicate, and it's not worth it. If you never get the part anyway.